As you may expect, 5G user plane redundancy is part of the ultra reliability features that are available with 5G. So those ultra reliability features are actually applicable to the signaling plane. So there's various techniques that can be used for signaling, but also for the user plane itself. So what you can see on screen is one of the main mechanisms for user plane redundancy, and it actually relies on dual connectivity. You can see that we've got a master G node B and a secondary G node B. So we know with respect to dual connectivity that that master will be in control of the secondary. So when a device needs to use high reliability, we will indicate to the network when we set up the PDU session that high reliability is required. So you might find, for example, in the signaling, the likes of a redundancy sequence number being provided to the network as a kind of flag to say we need redundancy here. There's different ways it can actually be done. So we can use things like UE route selection policy to also assist with user plane redundancy initiation. The end result though is essentially two separate PDU sessions being established. So in our architecture here, one of the PDU sessions is flowing through the master base station through UPF1, and then we set up a second PDU session through the secondary base station, but through a completely separate UPF. So totally separate UPFs and completely separate user planes, but both converging on the same data network. There are various techniques that could be available to the device to ensure that if we are sending redundant packets on each PDU session, that when they do converge at the data network, we can actually strip away the unwanted data, the redundant data. The one problem we've got with this approach is, of course, as we add more and more user plane paths, we're increasing the demand on that transport network. We're increasing the demand on the radio link, on the N3 connectivity, and beyond onto the data network itself, N6. So it's not without its kind of compromises, but devices that need this extra high level of reliability can use this technique. There is another technique that can be used, but it's not as comprehensive. And this is where we might have concerns about just the backhaul between the base station, the G node B, and our UPF. So if we've got concerns that the backhaul is the kind of point of weakness related to dropping packets, we can add redundancy just on N3. And that looks like this. So we actually set up two separate GTP tunnels on N3, and the likelihood is they would have separate paths through that transport network. Again, the problem is as soon as you double the number of tunnels, you are going to double the amount of bandwidth because the same data is going to be sent on each tunnel to provide the redundancy.